device settings, and I will go to, instead of EOS, I will go to HP Wide Vision. Yeah. Yes, I think I will be visible now. Little blurred. Okay, I need to remove the blur. Audio devices, speaker, Realtek. Audio devices, PC and mic. Yeah, I think it looks good. Then I just have to go for. Don't want to blur my. Okay, it's fine. How is the video quality? I'll just enable all of you to talk. We are a small group, so let me just see. Okay, so I hope this will be better. And let me also see if I can share a screen. Okay, so I'll just open up PowerPoint presentation and try to share with you on screen. Okay, so here you go, sharing my screen. Is my screen visible, guys? Okay, good. Okay, so we are all set. Let me just bring my digital pen. I need to write a lot, so I'll just bring my digital pen. Till that time, you guys please have your copies, pen and paper ready, so you can take a lot of notes. Okay, this meeting is getting recorded for future references, or if you drop out in between due to connection, I will upload this meeting on YouTube anyway. Okay, so we will start in a minute. I'll just bring my digital pen. Okay. Okay, so we had around 75 registrations, but I can see very few people. That's normal. So we are getting out of pandemic. That's what I say. And at the same time, to be very frank with you guys, we are getting too many inquiries by people visiting office. Instead of online inquiries, people now want everything to be offline. And that's a good thing, because that was always a favorite format for me. But online has some distinct advantages. You have a recording facility, you can share more things. All these things are a big advantage. So I'll just stop sharing and I'll start interacting. I'll ask few questions, guys. Just let me know if you are ready. Type in ready if you are ready, or just raise your hand and I'll start discussing. Okay, because we are starting with the session. Ready? Divya says ready. Anyone else? Vinita says ready. Good. Okay, good. Abhay says ready. Nice. Okay, so I want As you are putting comments, those comments are getting on my watch as well as on my mobile phone. So I just muted everything. Yes, Abhishek. Abhishek was invited to the meeting. Okay, fine. Abhishek joined. Yes. Okay, fine. Rohit joined. Abhay, Vinita, Divya, Manjunath, Prashant, and Peer Muhammad. Okay, nice. So we are a close group. I'll open everyone's mic after maybe half an hour, 30 minutes, 40 minutes, and we are dividing our session in segments. Okay. So first segment is going to be all about what LSDYNA can do. Okay, so we'll talk about what LSDYNA can do. That will just trigger your interest in this CAE or LSDYNA field. Then I will talk about what is exactly happening on ground level with regards to engineers and with regards to hiring. Okay, what companies are looking forward to. And the last segment will be how exactly this LSDYNA course proceeds. So Vinita has already joined this course. She is joining this uh, as a batchmate. But you guys have a little time to understand, and then you can also join in. I will discuss fee structure and all these things. Why I'm disclaiming this? Because this is not a sales pitch. Okay, this is not a sales call. I have purposefully mentioned that this is LSDYNA free session, session number 1 or 0, whatever you call it. So essentially, I'm not bluffing around. Okay, this is going to be a paid training. This is going to be a hand holding. I don't want to lie to you. I don't want to give you fake promises. At the same time, I don't want to keep you under dilemma that this is all going to be free. Okay, so first 60 minutes, we will 100% focus on learning. We will not do anything apart from learning. Next, maybe 5, 10, 15 minutes, we'll go for how exactly this LSDYNA course is going to proceed. And next, maybe 10, 15 minutes, we will focus on one important aspect, which is your questions and my answers. Makes sense, everyone? Type in MS making sense if this makes sense. Okay, so as I said, this is session 0. This is not something flashy kind of thing. This is all very basic, very core, and at the same time super interesting. Okay, I'm working in LSDYNA since last how many 18 years now, and I'm still not bored. So you can understand how deep it is. Okay, so I don't want to bluff around. I don't want to give you some. I saw a fraud. I'm not sure whether it is a good platform to mention, but as we are a close group, I can sure mention about it. I saw an institute, a large name, who is asking for OTPs, who is asking for Aadhaar card, PAN card, and then they are doing fraud about loans. And this is all about mechanical engineering. So that's something which is shocking. It just never came to my mind also. But people are very crazy to make money. They are less crazy to upgrade people. Okay, so I'm here to help you out. This is not my main earning source. My main earning source is my company, my organization, where we do defense project, railways projects, automotive projects. So I just want to keep it straight. Okay, so let's start with my introduction. My name is Nachiket Phadke, as you all know. How many of you are connected with me on LinkedIn by some or the other way, or on social media platforms like Telegram or YouTube channel or podcast I launched yesterday? All of you are connected. How many of you are not connected with me? Just raise your hand. You're not connected with me anyway. You're just receiving my emails and other bit, but you don't know who am I. Okay, Prashant is a new guy. That's good. Anyone else who is not connected with me, or who is not having any kind of interaction with me? Fine. So I'll introduce myself. I started my journey as graduate engineering trainee GET back in 2005. I am a Puneite. I lived in Pune. I'm still living in Pune. I had my all education in Pune, and I worked in Pune. I was there in US and Germany for a relatively short time of 3.5 to 4 years. because people live for much longer duration abroad. And I was working on two main components. Okay, first main component was seating system. I'm still working on seating system, railway seats, passenger car seats, and other bit. The second component which I work on is interior parts, which we call as dashboard. How many of you know dashboard, door panel? They are plastic parts. Okay, we call it as instrument panel. Dashboard is a layman's term. So we call it as instrument panel, door panel, floor console, headliner. All these things are interior parts. So my main focus since 2005 is towards automotive interiors. You can safely call it. In 2013, I started ELENO. Okay, ELENO is elements and nodes. So it is all focused about computer-aided engineering. Okay, so when we talk about ELENO, we are talking about two things again. One is training institute, ELENO Engineering Learning Center, which I take closest to my heart, and which is something as a mission for me. Okay, it's not work, it's not money making business. It's a mission to train young people into a hard skill, which is explicit dynamic analysis. I am on a mission to train almost 1,000 engineers in next couple of years in explicit dynamic analysis. And as I said, ELENO Engineering Learning Center is my mission. It's not my day job, or it's not something which just makes money. The second is ELENO Energy LLP and ELENO Engineering LLC. So all are ELENO names. And why I'm describing, because we all are engineers, so we should understand how exactly an organization works. So ELENO Engineering LLC is situated in US. My partner, Mr. Mayur Kulkarni, is actually looking after that. Then we have ELENO Energy LLP in Pune. We cater to defense, railways, automotive, marine engineering, general engineering, material handling equipment for explicit dynamic and some kind of a static analysis, including electric two-wheelers. So we are working on some exciting electric two-wheeler projects. We are working on electric three-wheeler projects. We are also working on electric buses. So this is all a combination of basic engineering, CAE analysis, and some amount of design. Okay, so that's all about me, and I would like to know from your side which city you are from, just to understand the demography. Okay, just type in your city name. I'll just read out in the chat box from which city you are. I'll just read it out. Abhay is typing Bangalore. Manjunath is from Bangalore. Abhay from Pune, good. Prashant from Hyderabad. Divya from Bangalore. Akshay from Pune. Akhilesh from Hyderabad. Vinita from Nellore, good. Anyone else? Okay, Ragul from Tanjavur. Wow, okay. Good connection of Pune and Tanjavur, because it's connected through Shivaji Maharaj. So that's good. Bangalore, nice. Okay. KKJ, I don't know your name. I think you are a rapper or a pop guy. I'm just joking. Okay, Mohammed is from Bangalore. Good. So it's good demography, but nobody from north side. Nobody from Delhi, nobody from Meerut, nobody from Ghaziabad or that bit. But Troy, okay, Rohit is from Troy, Michigan. Good, nice. So we have ELENO Engineering LLC in Novi for your own understanding. And if you need any help, Mayur will be happy to assist you. So later you can ask me Mayur's contact details. Okay. Good. Thanks a lot. Thanks, guys, for your feedback. And let's start digging in. Enough of introduction. For next 1 hour, 55 minutes to 1 hour, we will talk about LSDYNA. Okay. How many of you are excited? Type in excited if you are excited. Excited to learn? Okay. So thanks a lot. Thank you very much. Now I want you to make sure that you are not getting out of this session due to any other reason. So just I'll give you 30 seconds. I have also locked. I have a daughter with 6 years of age. So you know how annoying she can be. So I have closed myself. I have told him since morning that please don't disturb me in the evening time. Go to sleep. Go to bed early. That's what I have mentioned her. I want you guys to also just make sure you are focusing. Switch off your mobile phones. I have also switched off my mobile phone. Don't look at it. Focus on this. Focus is the key. That is something which is missing. So I want you to take 30 seconds of your time, switch off everything, just get rid of all the notifications, focus on this part, focus on this subject, and then we are going to talk about in a much better sense. Make sense? Okay. So when you are done, type in done and be ready with pen and paper. Okay. Be ready with pen and paper. I will be writing using a digital pen. Okay, switch off everything, cut down, ask your parents or your flatmates or roommates to not disturb you for next 90 minutes. Super. Thanks a lot, guys. Thanks, Manjuna. Thanks, Divya. Thanks, Vinita. Thanks for your confirmation. All of you done. I will just wait for more confirmation so that I understand. Thanks, Prashant. Thanks, KKJ. Thanks, Vijay. All right. Thanks, Akshay. Good, good, good. So just switch off. Focus is going to be the key. Okay, good. Okay, so let's start, guys. I'll share my presentation, and it's going to be more of animations and how exactly LSDYNA works and all these things. Okay. So here you go. I'm sharing my window of master presentation. There you go. Okay, so don't consider this as a corporate presentation. I'm using my corporate presentation to explain to you how LSDYNA works. Okay, so don't worry about it. There is no confidential information here. It's all shareable information, so you can easily share this video with your friends when I upload it on YouTube. Okay, so we have computer-aided engineering, CAD and technical services, training, etc., etc. All these things going on. These are some of our clients. Okay, so we will try and understand, as I mentioned earlier, we will try and understand use cases of LSDYNA first, and then we will go create an interest and go deep into what exactly LSDYNA does, what is engineering, what is it that we do, what is it that you must learn to become a CAE analyst, and the most important part, your career path. Okay, so we will be discussing about career path of a CAE analyst, how exactly you can grow and climb ladder inside the organization. That is something which I am more interested to share with you. Correct? Is it relevant? So how exactly is the career path? Is it relevant? Type in relevant if this is relevant to you. Okay, the understanding of becoming a CAE analyst and then going forward as a senior CAE analyst, lead engineer, senior lead manager, etc. Right? So we'll talk about this relevancy, and then I will have an open question and answer in between just to understand whether we all are aligned, and then we will move forward with the course content and other bit. Okay. So it is perfectly okay if you don't join any of my courses. So this is not a sales page. This is more like a industrial visit. Okay, you can call it like an industrial visit in your own room or in your own space. You can call it like that. And if you feel that I will be a good mentor to you, I will be the happiest person to have you on board. Fine. Okay. So here you can actually see a seatbelt anchorage test and a frontal impact scenario. Okay. So what I want you to do is observe. Okay. And what you have to observe, you have to observe these two pictures or these two, sorry. Yeah, there you go. So I want you to observe these two slides, slide number 1 and slide number 2. Both are same in the sense one seat is moving, one is not moving. That's just a visual effect. Okay, so don't observe in event of whether seat is moving or not. Both seats are moving. Just to visualize, I have fix this seat. So actually the seats are moving, actually the floor is moving. So what do you see in seat number 1 and seat number 2? Or sorry, yeah, the image 1 or movie 1 and movie 2. What's the difference, guys? Observe. That's the first important quality of any mechanical engineer. A very good observation. Frontal impact with dummy with seat belt. Belt, correct. Divya says belt. I actually written it. So that is strange, but there you go. So it was written, but as you can see here, there is a belt to this dummy, which is 3-point seat belt. Then we have no belt situation here. So this dummy has no seat belt. Okay, that's something which is the important aspect here. Rahul says with less shock. Okay, no, the pulse is exactly the same, Rahul. Then we have how seatbelt is reducing impact. Yes, Vinita, that's a good observation, that how exactly seatbelt saves your forward motion. Okay, how seatbelt saves your forward motion. So in this case, guys, what is it that we are doing? We are trying to compare the structural response. Okay, I'm writing it down here. You can also take a note of it. So we are trying to understand structural response in event of belted and unbelted dummy case. Okay, how exactly structural response? So you can actually see in this case the impact is not reaching, or the occupant is not reaching to the steering column. Whereas in case if you are not wearing a seat belt, you will be directly getting impacted through steering column and you are going to die on the spot. Because steering column is not made up of plastic. It's not going to absorb any energy. It is made up of steel. The column is also made up of steel. The wheel is also made up of steel. It is just wrapped around with polyurethane or any other polymer. So point is, whenever you are trying to simulate something in a dynamic scenario, we will have to first understand what is called as a dynamic load and what is called as a static load. Okay, so we will have two things to define: static load and dynamic load. So we will understand this case first. So I will be giving you a case and we will also define a few things. Fine. So let's understand what is static and dynamic load. Okay, so I'll just define dynamic load and the static load will automatically get defined. So I will define dynamic load as, you can call this as a definition, load which changes its magnitude and or direction with respect to time. This is called as dynamic load. Can you take this down? Just take down this definition. What is exactly dynamic load? A load which changes its magnitude and or direction with respect to time. So I will be explaining you on this whiteboard what is exactly called as a dynamic load and what is exactly called as a static load. Once you are done, just type in done, writing down this definition. Guys, my voice is clear, right? Okay. Fine. Thanks. Okay. Type in done. Once you are done writing down this definition, load which changes its magnitude and or direction with respect to time. So I will be giving you an example of a dynamic load and a static load. Now, of course, a reverse definition is going to be static load, where load does not change its direction and or magnitude with respect to time. Okay, so time here is important part, direction and or is important part. So either of it or both of them So that's something which is important. Done, everyone? Last 10 seconds. Done, done, done. I want you to write it down on using pen and paper. All right, good, 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 good. Okay, so Vinita says done, Prashant says done, KKJ says done, Divya says done, Akhilesh says done, Vijay says done. All right, all right. Manjunath says done. Okay, good. So most of you are done writing it down. Now let's understand the example. Okay, example of a static load and a dynamic load. You all know. I'll give you a problem statement. Okay, you all know shaft and a pulley. That is very common. Okay, you have a shaft and you have a pulley. Pulley mass is 100 kilogram, and this shaft in bearings. Okay, so this is not a simply supported beam, it is a fixed beam. When it is in bearing, the shaft becomes a fixed beam. Am I right or wrong, guys? So we will have to revise our strength of materials a little bit. So when it is under bearing, it's no more a simply supported stuff, it is going to be a fixed beam. So we have this 100 kg mass pulley which is having weight downward, moving downward, and it is rotating at a speed of 300 rpm. And imagine, which is quite possible, the entire system is balanced. The entire system is balanced. That means there is no imbalance mass. Okay, so what is this if this particular system is running at 300 rpm with 100 kilogram pulley mass? Is it a static load on shaft or is it a dynamic load on shaft? Let me see how many of you are answering. Correct or wrong doesn't matter for me. Is it a static load on shaft or is it a dynamic load on shaft? Okay, Ragul says dynamic, fine. Vijay says dynamic. Akhilesh says dynamic. Prashant says dynamic. Now the typical thing is the first answer actually decides the overall path. Vinita says dynamic. Abhay says dynamic. Rohit Singh Lal says dynamic. All right. Any other answers, guys? So what I suggested, it's rotating at 300 rpm. Mass of pulley is 100 kilogram. It is a balanced system. There is no imbalance mass. So what are the loads? Are they static loads or dynamic loads? Okay, and most of you answered it as dynamic loads. Okay, now we will go to our definition. Okay, let's not confuse ourselves. We'll go to our definition. Load which changes its magnitude and or direction with respect to time. Now let's come back to the image. What is the load? Load will be 100 kilogram multiplied by 9.81, that is G, correct? Yes or no? So imagine 10. So we have 1000 Newton of load. 981 to be precise. Fine. So we have 1000 Newton of load. Imagine. Is that load changing its direction? What is the direction? Direction is downward. As it rotates, is it changing its direction? Yes or no? Is load changing its direction? Yes or no? No. Okay. So first condition is the load is not changing its direction. Okay. Then is this magnitude getting changed? Are you changing mass? Are you changing? Are you adding something? Are you subtracting something? What about mass? Is it changing? No. Vijay says no. Mass is not changing, right? It's same. Load is same. Magnitude is. So you have magnitude same and you have direction same. Can this comply to the dynamic load definition? No. Why it will go to fatigue, Ragul? That's not the case here. If you have an infinite life, right? You know the concept of infinite life. It will not go, it will have an infinite life if it is all made up of ferrous alloys, right? It will not go under fatigue. See, I'm talking about dynamic load and static load. I'm not talking about fatigue. Fatigue always comes under static load situation, or it always comes under a situation where you will have loads less than its allowable limit. Yes or no? If you have loads less than your allowable limit, you're going to have, this is not a unit load, Rohit. Okay, remember, this is not a unit load. It's a load which you can measure. It's not a unit load. What I'm talking about is fatigue will only occur when you have non-infinite life or non-ferrous alloys. But if it is a ferrous, typically the shafts are made up of steel, right? And you have an infinite life, or practically infinite life. I'm not talking about theoretical life. Practically, you will have an infinite life. Okay, so let's not divert ourselves to fatigue. That's not the condition we are talking right now. Okay. So when you have load which is not changing its magnitude, not changing its direction, what you call it? You call it as a static load. Yes or no? Correct? Are you with me, guys? Type in with you if you are with me. WU. Type in WU if you are with me. Got my point? So this is a pure static load. Now, wait, I'll explain you. One more thing. Same setup, exact same setup. I'll just exaggerate. Okay, you have shaft, and guys, my drawing is very good, but this pen is very slippery. Okay, so just bear with me. This is not my drawing. Okay, so if you give me pen and paper, I'll be excellent. So you have bearing, you have same pulley, and now I have a side view. Okay, I'll just draw a half side view. Fine, and you have this as an imbalance mass, which is at radius r, and mass is m dash, imbalance. Now, what is the, and it is rotating at omega, whatever 300, 400 rpm. So what is going to happen with centrifugal force, F centrifugal, m dash r omega square. Am I right? Correct? Yes, Vijay. If it is not well balanced, then only it will become a dynamic load. Absolutely right. And practically, I'll tell you guys, if you go to any fast rotating system, 99.99% is possible. In a practical way, it is possible. Okay, balancing with 99.99% accuracy is possible. So practically, it becomes fully balanced system. Now, what is happening, guys? This m dash r omega square, which is Fc, is created with same magnitude. So magnitude is not changing. But can you see now, if the pulley rotates, the bearings are going to experience load which continuously changes its direction. Do you remember a factor called Kc, which is in bearing design or bearing selection? We don't design bearings, we select bearings. So if you go to Kc, or dynamic coefficient, you will see how much is the dynamic load, and this becomes a pure dynamic. Why it becomes a pure dynamic case? Because load changes its direction, not the magnitude. Are you with me, guys? Following me? Just type in F if you are following me. If you have a question, raise your hand and ask question. Just type in F if you are following me. What is static load? What is dynamic load? I'm going very basic. Okay, but as you can imagine, most of you gave a wrong answer. I'm okay with that. Okay, I'm not scolding you, or I'm not judging you based on it. What I'm trying to tell you is the real life situations will be a little different, and that's what you have to imagine. So what you are following me, you are following me that if I have a balanced system, if there is no imbalance, and if I have same magnitude, same direction, which is not changing with respect to time, I call it as a static load. Same system, I introduce an imbalance. It creates a centrifugal force. So you can imagine you have a bearing and the pulley is actually, when it rotates, the imbalance mass keeps on changing its direction, and you can experience, the bearing can experience a pure dynamic load. Yes or no? Clear? Okay, so this is a dynamic load which is only changing magnitude. It's not only changing direction, I'm sorry. It is only changing direction, it is not changing magnitude. Okay, magnitude is m dash r omega square. Now let's move forward. We have one more thing which is called a dynamic load which continuously changes its magnitude and not direction. So imagine this is a rooftop, not rooftop, a balcony, a cantilever balcony or a bridge. So this is all fixed. This is a cantilever balcony. You guys are having a good time. A party is going on and there are people standing. Okay, there are people standing and you are talking to your friends. Some people are sitting down, some people are standing up, some people are walking. What is happening? The load is changing its magnitude, but the load direction always remains downward. Same thing with bridges. You have a bridge, the vehicles are moving. One time a cyclist is going on, one time a bus is going on, one time there is a bullock cart, one time there is a large crane. All of them are actually moving and the magnitude changes, direction remains the same. Will you call that as a dynamic load? No. What is this? This is a dynamic load example where magnitude is changing, direction remains the same. Load on the balcony is dynamic. Divya, yes or no? No, you call it as a dynamic load. It is a dynamic load. It changes its magnitude, but the direction remains same. All right, clear everyone? So what I actually started discussing, I started discussing with regards to the seat, where you will have a dynamic load or where you have a time dependent factor, correct? And I wanted to clear this stuff. Are you learning something, guys? Type in learning if you are learning something. Learning something? Okay, good. Okay, so I don't want you to just stay here and don't do anything. Okay, you are learning something. That's something which is positive for me. Fine, good. Okay, now let's talk about a very important case. Okay, we will talk about this. I have already created a video when I was standing on an express highway, but that video is already there on YouTube. But I will still explain you 3 important cases in life of a designer. Okay, 3 important cases in life of a designer. One case is static load, static design. That means you use static design principles of force is equal to stress is equal to force per unit area. That's a simple static load static design equation. Okay, the first case of a designer's life, static load static design. Sorry. Then we have dynamic load. Dynamic load, which is converted to a static equivalent. That's why we call it as load is dynamic, but the design principles are still static. Classic example I gave you is balcony, bridges. So what do? You know how much should be the bridge capacity. So you are going to convert a particular case. Let's imagine you are going to travel on the bridge using a bus or a large truck of 25-ton mass. So you know the mass, you know how much is going to be the load, and you will multiply it by some exuberant number of 10 or 15. So what you are imagining? You are imagining something which is over capacity, because by design it should sustain maximum load of a given application. It's not design, it's not something which you create every day. You create a bridge which lasts for maybe 100 years or maybe 70 years, 50 years, whatever it is. So absolutely right, Akshay. It is a worst case scenario, but it's not a dynamic load. That means you are not computing the bridge based on a load which changes its magnitude and or direction. So you have a dynamic load, but you convert it into a static equivalent. So all of these civil structures are typically falling under this design principle. Roads are having dynamic load, balconies are having dynamic load, dams are having dynamic load, bridges are having dynamic load, metros are having dynamic load. All these are dynamic loads, but we convert it into a static equivalent and we call it as dynamic load, which is calculated using a static design principle of stress is equal to force per unit area. The third is what we are focusing on. Load is dynamic and design is also dynamic. That means you are following this principle. Force is equal to mass into acceleration. That means you are considering time when you are designing something. For example, crash, for example, blast, for example, high speed impact, for example, bullet penetration, for example, drop of this pen, for example, drop of my mobile phone or this camera or this laptop. So whatever is happening in real time. You are not converting that dynamic load into a static equivalent. Are you with me, guys? Clear? I've been clear if these three scenarios are clear for you. Clear. Understanding this? Okay. So I want you to write down this table in next 20 seconds with examples. Okay. I want you to write down with examples these three cases of static load, static design, dynamic load, static design, and dynamic load, dynamic design. Okay. And then I will explain you why we need CAE. Okay. That's going. Okay. They are static loads. Ragul, they are static loads. Lifts and escalators are over designed parts. They are safety parts. They are always designed for considering a static equivalent of a dynamic load in an exuberant number, 10, 15, 20 times the load. Okay, so they are coming under second category of dynamic load, static design. Now, I'll just clarify. Imagine you have a scenario where the lift actually or the escalator, not escalator, I'll say the elevator. Escalators are typically not going to fail. They have a static kind of a design. If they stop, you can still climb these stairs. Elevators or lifts, what you call, the elevators may fail with their brakes, and if they drop down, there will be shock towers or there will be some impact absorbing components. That comes under dynamic design. The entire elevator may not come under dynamic design, but the shock towers will sure come under dynamic design. Making sense? Clear, everyone? Type in done once you are done writing this. These three important things. If you need more time, I will give you more time. But I want you to be very clear, close your eyes, try and imagine a situation where you have a static load and a static design. For example, table. For example, you have chairs. So a simple case, you have dynamic load, static design where you will have balconies, bridges, and other bit as I mentioned. And dynamic load, dynamic design. So try and imagine and type in done. Done, everyone? Done. Last 10 seconds. Let's see how you do it. Okay. Good. Vinita says done. Manjunath says done. Prashant says done. Abhay says done. Okay, good. KKJ says done. Wow. Rohit says done. Rahul says done. Okay. Good. So almost all of you are done there. Okay. So I didn't call out some names. I'm sorry, guys. But Ananta Shayana. Okay. Aniruddha is there. Then we have Leo. Then we have Muhammad. Then we have Prashant, Ragul, Rahul, Rohit Singh, Rajat Kumar Sharma. Then we have Vijay and we have Vinita. Okay, fine, fine, fine. So we have some 19 participants. So that's a good number. I'm happy with it. Okay, okay, okay. Done, everyone. Good. So Ananta Shayana is also saying done. Good. So let's move on. And I'm going to talk about what was the topic I just mentioned you that we discussed about static load. We discussed about static load, static design, dynamic load, static design, dynamic load, dynamic design. I'm supposed to discuss about, one second, I mentioned something. Can you remember? You remember, guys? I'll get it through, but I'm just trying to understand. Is going to be why we need FEA. Okay, okay, okay. Yes, correct. Thanks for reminding. Okay, so we are talking about this, and we will talk about why we need FEA. Okay, before we go for, okay, I'll write it down. Why we need FEA or CAE. Okay, we will try and understand what is exactly happening or what are the key components of FEA. And before that, I will just give you one simple example of model and a prototype. Okay, so just let me pull one of the other file. Yeah. Guys, can you see my others? One second, I'll just share the other screen. Share. Thanks, Prashant, for reminding. So here you go. Share my other screen. Yeah, the image is visible, right? Visible, type in visible. Yes, okay. Yeah. So we will talk about this part. Okay, and this part is a simple part. Where is it? Yeah. So we'll talk about definition of a model and definition of a prototype. Okay. So tell me, before I define, tell me if left one is model or right one is model. Those who think left is a model, type in left. Those who think right is a model, type in R. Right is a model. Okay, fine. Prashant says right is a model. Akhilesh says right is a model. Okay, so when I say model, I'm not talking about person standing in the picture. Okay, don't take me wrong. I'm talking about car. Otherwise, you will say there is someone who is standing in the picture. That's why I call it as a model. I'm not talking about that person. Okay, about cars, whether left one is the model or right one is the model. So L, Divya says L, KKJ says L, Akshay says L. Then we have Anirudh who is saying R is a model, Vinita saying R is a model, Akhilesh saying R as a model. Abhay is saying R as a model. Okay, good, nice. So we have some good combination of left and right. GSDGS. I don't know. Can you edit your name, please? I cannot. I cannot understand. Or you can type in. Rohit says all L is model, left is model. Okay, and R is prototype. Fine. Ragul says R is model. I'm asking about model. I'm not asking about prototype right now. So Rohit's answer is L is model. So we have L and R combination. Harish. Okay, fine, fine, fine. Harish, I will remember your name. Okay, fine. So I will define, and now I will ask answers again. So what is a prototype and what is a model? So first I will define prototype. The model automatically gets defined. Prototype is 1:1 working model. Model can be scaled and may or may not work. Tell me, based on this definition, which one is the prototype and which one is the model. Is left one a model? Rohit said left as model, Rahul says left as model, then Manjunath says left as model, Divya says left, said left, KKJ said left, Akshay said left. So can you understand what is a model and what is a prototype, guys, now? A prototype always works. A prototype you cannot scale up or down. So what you see on the left side here, I'll bring that picture again, is a track going car. It's on track, it's working, it has engine, it has gearbox, it has person sitting in wheel, everything. Whereas this can be a clay model. That means it is 1:1, but it is not working for sure. It doesn't have an engine, it doesn't have a gearbox, it's not having any drivetrain, it's not having maybe real steel components also. Getting my point? Okay, so what is model? Right is a model because you can scale it up. For example, if you want to do a wind tunnel testing in case of aircraft test, okay, and you have this Boeing 747 or 787, a newer version, and you want to have a wind tunnel testing to be done, coefficient of drag to be found out. What is it that you are going to do? You will go ahead and scale that entire 787 which fits inside the wind tunnel. Yes or no? That is called as a scaled model. You don't have a term called scaled prototype. Correct? So left one is a model. Sorry, left one is a prototype. I'm sorry. Left one is a prototype. Right one is a model. Are you with me, guys? Understanding something? Type in clear if this concept is clear, because that is directly related to CAE. This concept is directly related to CAE. That's why I cleared this concept. Type in clear if this is clear. Okay, Harish says clear, Prashant says clear, KKJ says clear. Okay, Ragul says clear, clear. Okay, I want you to take this down because I will be explaining you virtual prototyping, which is CAE. Okay, so the next part is virtual prototyping. So I want you to just take this definition down. What is a model? What is a prototype? Okay, and type in done. Once you are done writing, I will just open this definition part here. So model can be scaled and may or may not work, whereas prototype is always 1:1. So you cannot scale it. You cannot call anything as a prototype as soon as you scale it. And it should be working. It must work. Then only you call it as a prototype. Never call it as a prototype if it is not working. Type in done if you are done writing down. Then I will explain you what is virtual prototype, and we are coming to an answer why we need CAE. So the question was why we need CAE, and that's why I explained you what is exactly model and a prototype. Okay. Good, 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 good. Okay, KKJ says done. Prashant says done. Take your time. It's okay. Can be little slow, but I want you to learn. I don't want you to skip anything. All right. So we will go to why we need CAE. I'll just stop sharing this particular screen. Model and prototype done. All right. Good. Nice. So done, everyone. Last 10 seconds. I'm enjoying because you guys are super active. So thanks to you, and thanks for giving answers and be interactive. Okay. So already 1 hour is done. So that's a good thing. So we learned few more. We are supposed to learn few more important concepts. So we'll go forward with it. Okay. So here you go, guys. I'll share the screen. So we have a question why we need CAE. We will understand what is virtual prototype. Okay, so when we go into a CAD tool, a 3D design tool like CATIA or Creo or UGNX or whatever it is, this CAD tool is actually generating a 3D model. Now you will understand what is happening. You are generating a 3D model. You are not generating a 3D prototype when you are in CAD. But as soon as you enter into CAE, what do? You assign material, you assign boundary conditions, you assign loads, you assign constraints, and you assign all these things to generate a virtual prototype. So what is virtual prototype? It is actually not existent in physical form, but it is behaving exactly like a physical activity or physical part. So what you see here, see this. This is one of the virtual prototype of an unguided vehicle or guided vehicle. I'm sorry, guided vehicle, unmanned guided vehicle. So what is it? It is actually having the correct mass. It is having correct materials. It is having correct boundary condition, correct velocity, correct constraining. And then we are simulating it. We are generating what? We are generating a virtual prototype. This is not a CAD model. Okay, so we call CAE part as virtual prototype. We call CAD part as 3D model. Clear? Clear about this? Type in clear if you are clear with virtual prototype. We will talk about virtual prototyping techniques now. Okay, you are clear? Type in clear so I can move on. Okay, so virtual prototype is not a 3D CAD model. It is 3D CAD model with assignment of material, boundary condition, loads, and other bit. Okay, good. Now let's understand what are the types of CAE techniques. What are the virtual, and this virtual prototype is called as computer aided engineering, CAE. Okay, so what CAE comprises of? It comprises of finite element methods or analysis. It comprises of discrete element methods. It comprises of computational fluid dynamic. It comprises of electromagnetic studies. It comprises of chemical studies. It comprises of SPH. It comprises of radio frequency analysis. So everything which can generate a virtual prototype is called as computer aided engineering. Have I cleared some of the doubts about CAE, guys? What is CAE and what is FEA? So finite element analysis is a part of bigger umbrella called CAE. Finite element analysis is part of bigger umbrella called CAE. But CAE is not just FEA. Okay. So whenever you have structural analysis, whenever you have to do something related to stiffness matrix, you are using finite element methods. Whenever you have to do something related to flow, temperature and other bit, you are using computational fluid dynamics. Whenever you want to do something related to electromagnetism, you are going to use EM as a solver. Is this clear? So whenever you are going to search jobs, there will be a position called CAE analyst. There will be a position called design engineer. There will be a position called FEA engineer. So there will be positions, but you have to first understand what exactly is the role. What is it that you are going to work? Type in CAE if you have understood CAE concept. Type in CAE if you have understood CAE concept. Understood? If not, you can keep that question ready. You can just keep that question and ask me in a question answer session. I will open mics to everyone and then you can ask questions. Okay. Clear? Okay. So what I showed you right now was an application of virtual prototype. This was an impact done on unmanned guided vehicle, a military application. It was hitting on a rigid wall and we wanted to understand what happens to the front bumper, whether we can replace it on field or not. Okay. Now I'll give you a similar example here, an animation of maybe 1 second. Let me see what animation I can show you. Yeah, in defense, I'm sorry. In defense applications, I'll just show you one of the. Yeah, you have this undermine blast without hull. So this is a mine blast situation, and this is one more mine blast situation where you have with hull and without hull condition. Okay, so under vehicle mine blast simulation with hull and without hull. So this is coming under a pure dynamic load. Now we are trying to understand one step at a time. We first understood, okay, let me summarize. Let me summarize in one of the page. 1 second, let me summarize because I don't want you to get confused where we were and where we started. Okay, so I'll create a summary here. Summary is we started understanding design. Okay, we started understanding dynamic load, static load. We started understanding, okay, so I'll write it down like this. Types of loads. Correct me if I'm going wrong. Okay, so you can message me. Types of loads. That's what we talked. A dynamic load and a static load. Correct? We defined this. Then we talked about types of designs or design 3 design principles, I'll call it. Okay, so you have static load, static design, you have dynamic load, static design, and you have dynamic load, dynamic design. Then we talked about what is model, what is prototype. Okay, then we talked about virtual prototype. And then we talked about what is exactly CAE and what are the methods in which you can solve various problems in CAE. And finite element method is one of that method. Clear? This is correct. This is what we discussed. So I'm just trying to summarize it. All concepts clear? Type in clear if all concepts are clear. So we discussed 5 important concepts in less than 1 hour. So you can understand how powerful it is to understand concepts using examples. Yes or no? Okay. Powerful, useful, learning. Whatever is you're feeling, you can type in. Okay. It's powerful, right? You can learn much faster when you are actually having examples in front of you. Correct? So this is something which is the basic part of why exactly what is happening in CAE. We haven't still answered question why we need CAE. Okay, so the question is still there. Now we are coming to the question, a real question, why CAE? Okay, there is a single line answer. Anytime you have an interview question, why exactly you are doing CAE or why exactly you are doing FEA. The single important answer is to reduce number of physical tests and accelerate time to market. Why we need CAE? We need CAE to reduce number of physical tests and to accelerate time to market. It reduces cost, it reduces time, all these things are there, but they are the byproducts. The main aim is to reduce number of physical prototypes. Why? Okay, number of physical tests, or I'll even write it down as physical tests and prototypes. Okay, so I'll write it down like this or rewrite like this. Okay, and accelerate time to market. Now I'll just explain you why we have to reduce number of physical prototypes. Okay, so a prototype car. Okay, imagine you have Tata Tiago, a small car, smallest car in Tata's arsenal right now. That car costs around 7 to 10 lakh rupees. Am I right? On road. Okay, around 7 to 10 lakh rupees in between. So this is on road price, not proto price. So this is on road. Typically, when the car is in a concept stage, when it is not on road, when you are actually evaluating various parameters, the proto cost will be roughly 15 to 20 times. 15 to 20 times that of on-road price. So you can imagine if you are having 40 prototypes made and you save some, let's say 15 or 20 prototypes, that means you save some proto cost. How exuberant this cost will be. So car costing around 70 lakh rupees as a proto or 60 lakh rupees as a proto will be a huge cost saving as far as CAE is concerned or any organization is concerned. At the same time, it accelerates your time to market. What CAE does, it accelerates your time to market. Understanding this? Clear? So proto costs are exuberant. Why we need CAE? We need CAE to reduce number of physical tests and physical prototypes and accelerate time to market. Type in proto if you are understanding this part, because it is all related to prototyping. Nobody does CAE just for sake of it or to validate the design. They do CAE to reduce number of prototypes, they do CAE to reduce number of physical tests, and then they reduce CAE to make sure that you are faster as far as the time to market is concerned. So when I say number of physical tests are reduced, I don't mean to say that you are actually eliminating some of the tests. What I mean to say is you reduce same kind of a test done on similar part for many number of times in physical form. It should be a test carried out, then a test carried out, then a test carried out, and that should be just a compliance test. That's all. Clear? So you got an answer why we need CAE. Okay. Clear, everyone? Okay. So these are the concepts which I really wanted to push in front of you to understand or to give you an understanding what is exactly happening. Now we will talk for next 5 minutes about what is exactly happening as far as the career of a CAE analyst is concerned. Okay, a very important aspect. A CAE analyst, I'll start with a GET position, GET or a PGET position. Now there is a myth that a graduate engineer cannot join a CAE department. I'll show you some of the job descriptions from various organizations where they mention BE mechanical / ME MTech mechanical design. They will never explicitly say that we only want a MTech guy. That is only if the organization is big and only if it is a campus drive. They will ask for a PGET. But if it is an open market scenario, a graduate is more than sufficient for CAE analyst position. First myth, okay? I'm clearing this myth because there are too many questions for me that can I do MTech to enter into CAE? The answer is you should not do MTech to enter into CAE. You should do MTech to learn something which you never learned in your graduation. Not to enter into CAE. You don't need MTech to enter into CAE. Okay, that's clear. First thing. Second, you start this journey for maybe 1 year. 1 year you will be GET or PGET. Now what is happening? You will get trained on various tools. So tools are not important here. The important part is system. How exactly the system works. What is a pre-processor? What is a solver? What is a post-processor? You can actually go on my YouTube channel, ELENO Engineering Learning Center, and you can see the entire session which I conducted on pre-processor, solver, and post-processor. Okay, so that entire session is almost 1.5 hours. And that there I discussed about what is pre-processor, what is solver, what is post-processor. So that session will be super useful. Now the CAE analyst position is going to get filled first as GET. So you'll be starting at GET, PGET, you'll work for 1 year. You are going to get a confirmation from organization maybe after 3 months or 6 months of your probation period. So probation is good for both. It sometimes happens that organizations will tell you that you are going to do this, but in first 1 month you understand that this organization has no capacity to handle this kind of problems. In that case, you have an escape plan. You can simply say that whatever you said, you are not actually keeping your promise. So I am in a probation period and this is my last day, I'm leaving. At the same time, it's both way, okay? It's not one way. At the same time, you can have, this happened with some of my students also. They were told that they are going to work as analysts, but they never worked as analysts because they were only being fed with the meshing job. And they were good at meshing. They were interns at my end and they did a very good internship. And when I placed them, they said, no, we are not working on any kind of an analysis project. So you'll have to keep on working as meshing engineer. And that's not a good scenario. Okay? That's never a good scenario. So it is better that you have a probation period. It's good for both of them, both of the parties, employer as well as employee. Now, the next part is going to be a CAE analyst part. Typically, you should stay here for another 1 year, this position. Here you are going to apply knowledge which you acquired as GET or PGET and try giving solution to customers. Your customer can be the in-house customer, it can be an outside customer, anyone. Then you become senior CAE analyst. Then you become a lead engineer or lead analyst. And then you become a senior lead analyst and a manager. Okay? Now, typically what happens, I'll tell you. Senior lead and manager and other bit, okay? So you are climbing a ladder. If the organization is large, you will be climbing ladder slow. If the organization is medium, you will be climbing ladder faster. But if the organization is a small organization, when I'm talking about organization, I'm talking about CAE as an organization. Okay, so you may have a large organization, but a CAE department is small. You may have a small organization, but the entire organization is CAE department, like ELENO. So it all differs. So if you have people who are in range of 20 to 25 people working in CAE, the rate of growth is faster. If you have 100, 200 engineers working in CAE, the rate at which you are going to grow is slower. But with one CAE analyst, typical engineering service provider will have 5 design engineers. Okay, so if it is 1:5 ratio, a typical ratio. So if the organization is having 10,000 or 5,000 design engineers, there will be almost 800 to 1,000 CAE analysts. Are you with me? Clear? This is going to be a very simple path, but a sustainable path. There are no layoffs in CAE. I have never heard of a layoff in CAE department. I never heard of a layoff with regards to a product getting developed, and unless the company gets closed down, like what happened with Arrival. So Arrival was a big UK-based bus manufacturer, but they closed down their operations, and everyone was jobless. But that's something which is happening with almost all these startups, and that is not happening with conventional players. Okay, so you'll have a very good path with regards to a CAE analyst position. Now we'll come to packages. How many of you want to know a typical package? Type in me. If you want to know the typical packages and how exactly the growth is. Okay, it's not a secret, but I will be just sharing with you. There is an organization called ADADA, plus ADADA. There is an organization called ADient. There is organization called Magna City. There is organization called Foratia. Fresher package. For GET, I'm talking about graduates, and I have placed some of my students, is 5 lakh per annum as a GET minimum. Is it good, bad? All depends on your mindset. Okay. In my opinion, it is good to start with. Mahindra, it has similar package. Then even OEMs have a better package, but these service providers, I'm talking about service providers who are having 5 lakh to 6 lakh as their starting package. Okay, I'm talking about GET again. Now, what does it mean? It simply means that you are a part of organization where a cost center is getting paid more. See, you have to understand organizational structure. In IT, whoever is working on on the product is actually working on a product itself. Whereas in case of R&D engineering, or in case of automotive engineering or any kind of mechanical side, R&D is itself is a cost, because manufacturing is where you are actually churning a lot of money. But R&D is going to be a cost for everyone. Making sense? So when you are talking about R&D, because when you enter into CAE, you are entering into an R&D organization. And in that case, people are ready to invest in you, even if you are knowing too little things, they are still interested to invest, and that's a good correction which has happened. Okay, so this is a real-time scenario which I am trying to put in front of you. So if we are going to do a placement assistance, I'll just take you to the path, because we have 4 minutes left with my sales pitch, and then we will have a question answer session. So if I just want to explain you the entire path at ELENO and the fee structure and other bit, I'll just explain to you. We have two main courses, or I'll say 3 main courses. One is Hypermesh, other is LSDYNA, and third one is seating system. Okay, seating system CAE. And I do have an option for full vehicle and interiors, but this is like a pro option. Okay, so just let's talk about a seating system right now. So we have Hypermesh course, which is at 13,999, LSDYNA course, which is at 42,999, and then we have seating system course, which is of an equal amount, 42,900. It's a big course. So my suggestion for those who have attended right now is these 2 courses. Don't go for seating, because we cover most of the things about seating system basics, modal analysis, seatbelt anchorage test, frontal impact, or even luggage retention. So that's something which we cover. This is for someone who is already working in Hypermesh, LSDYNA, and wants to grow. So you can just focus on these 2 parts. There is no discount even if you join combined. But the thing is, we are in a process of increasing fees by some margin from 1st of April. Okay. So if you want a hand holding from my side, if you want a lecture like this, on Wednesday, Saturday and Sunday. We are going to have these kind of lectures every Wednesday, every Saturday, every Sunday as question answer session and as theory lecture. Okay, so it's all going to be hand in hand. So when we are talking about HM and LSDYNA, we are going to cover too many things and there will be some bonus classes. Bonus classes will be basics of engineering, seating system as a product. Okay, then we will have LS pre-post and we will have Fusion 360. So these are going to be your bonus classes. The next bonus class is going to be very important, which is called CIWC, crack interview with confidence. Okay, crack interview with confidence. Making sense? So this is all going to be about your LinkedIn profile, your resume, how exactly you are going to proceed in your company shortlisting. What is it that you should be asking? What is it that you should be preparing? What are the things which are supposed to be done in the interview and after the interview? All these things are going to be taken into account in these 4 important classes. Okay, because basics of engineering is must. See it as a product is very important. You will just it will just open your eyes how exactly a product is getting developed. And of course, tool wise, Hypermesh and LSDYNA is going to be very important for you to start your career as CAE analyst. As I said, we will have this offer open till 31st of March. We will be increasing our fees from 1st of April. We haven't revised our fees since last 2.5 or 3 years maybe. So it is need of time to increase fees a little bit. But if you want to take advantage, I'm not increasing it by exuberant amount, but 5-10%. If you want to take an advantage, talk to me, enroll with me. We will have these kind of sessions. I will also try and clear doubts right now. Okay, so I'll open mic for everyone. You can raise your hand and you can talk to me about any doubts you have in the session, not just about fee structure. You can ask any doubt if you have. So I'll just go to the mic section. Okay, what is LSDYNA with OpenFOAM? No. We don't teach OpenFOAM. So Rajat Sharma, okay. So 1 second, guys. We have settings and device settings. Yeah, meeting options. There you go. So I'm enabling microphones. Yes, Harish, I will answer your question. 1 second. Allow mic for attendance. There you go. Okay, so now I want you to mute yourself, raise your hand, and then if you are unmute, just mute yourself, raise your hand, and then unmute and talk. Okay, so we have a question. Guys, can you see Q&A part in front of you? Is it there? I'm not sure whether you can see it or not. Okay, so Harish has a question. How does LSDYNA used in aerospace? So there are 2 applications in aerospace industry. One application is bird strike, bird hitting on aeroplane wing. And there is second application, which is blade contamination. Okay, so these 2 applications are actually solved day in, day out by aerospace companies using LSDYNA. Okay, that is something which is important. What will be the duration and mode of LSDYNA course? It is all online. I'm very sorry, I forgot to mention. The course duration is going to be for 3 months, only for LSDYNA. And we are going to have the entire LSDYNA covered with a hybrid mode of some recorded sessions, some live sessions, always a question answer session, and many problems. Almost maybe 10 or 15, 10 to 11 problems are minimum. Okay, that's what we are going to do. What is meant by crash pulse? Is it means the vehicle during crash or rebound? No, it is during crash. So it is as soon as it hits the rigid wall, what is exactly happening with regards to acceleration? So very good question. Crash pulse is typically a time for which the acceleration curve is plotted in event of a crash. So crash typically exists for 100 to 150 milliseconds. So zero point 0.1 to 0.15 seconds. That's a typical crash sequence. After that, it is all coming in equilibrium. Okay. All right, so you're open to ask any questions. Hope you understood whatever we discussed. Hope I tried to clear some of the myths about CAE, and hope you have. If you have any questions, just ask me. Anything about course, I will be sharing a course PDF with you as an attachment. So don't worry, the course PDF will be with you as an attachment. You can go through it, and you have those payment links also. You can enroll for it. You can avail a Visa or a Mastercard credit card EMI option. That's also possible. Somebody's typing. Okay, guys. Apart from this session related stuff, if you have any question, you can still ask. If I give crash pulse as input, it should be forward direction. It depends. It is supposed to be the rearward direction, because when the crash happens, the vehicle tries to move rearward. Okay, but if you are having a sled, got my point, right? So the frontal impact happens when the vehicle moves rearward. It's not going to move forward. Okay, so I'll just share this window again. Yes, any question? Prashant, Vinita, Abhay, Akhilesh. Vinita is already enrolled. Akshay, Anirudh, KKJ, Ragul. Any questions you have, just let Divya, if you have any question. Ananta Shayana. Leo, if you have any question, just go ahead. Harish, if you are having any question, just let me know. Okay. So I think there are no questions. I just want a final feedback. Whether you learned something, type in learn if you have learned something. And if you are interested in this course, I will be anyway sending you the course details. The course is open till 31st of March. These same fees. Later you can just go with the course with some little bit of a raise, so you can save some amount here. Okay, useful, right? Thanks a lot, guys. Thanks for attending. It was an amazing session, and thanks for listening to me patiently. It's getting recorded, so I'll just edit some of the part in the meeting and upload it on YouTube for other friends who could not join. Okay, see you then, guys. I'll stop the meeting now, and we will see you soon. As I mentioned, I have a podcast, I have a YouTube channel, I have LinkedIn, so you can join. Uh, you can join anytime, and that's perfectly okay. Yes, you can, but there is no regulation for three-wheeler crash, Ragul. Okay, there is no regulation. You can do as an OEM test. You can do a crash pulse with regards to car crash, but as I said, if you are going for full vehicle, you just have to apply velocity. If you are going on seat, then only you have to apply the crash pulse. Okay. Bye, guys. See you then. Have a great night ahead. And if you have any question, okay, I'll just type in my LinkedIn, my mobile number where you can connect me on WhatsApp. 9881732144. This is my mobile number. Then this is my link for bit.ly/Nachiket Phadke. This is my link for LinkedIn. So you can join me on LinkedIn. Any questions? I'm super active there. Thanks KKJ, thanks Akshay, thanks Ragul. So you can join on any of the link. Follow me. We have podcasts also. You can follow follow me on podcasts as well. Okay. See you then, guys. See you, Prashant. See you, Divya. See you, Vinita. See you, Akhilesh, Akshay, Ragul. Thanks a lot, and we will meet soon. Okay. Bye. Thanks, Leo. Bye. See you. Thanks, Prabal. Bye, guys.